Welcome student. In interference of light, we studied that when two or more light waves overlap to each other, they get superimposed. And when they get superimposed, there is interference can be determined. There are two types of interference can be formed. One is constructive interference and another is destructive interference. In constructive, we can determine bright light can be formed, and in destructive, we studied darkness can be formed. Alternate bright and dark can be followed by one another. We studied interference of light. For determine well interference, we have the both light sources must be coherent. That is, now we studied that coherent sources of light. What is meant by coherent sources? The two sources which emit same frequency, having same phase difference and same independent of time. That is, if two light wave travel with same frequency, same phase difference, same amplitude, and if they get overlap to each other, interference can be formed. That interference is determined alternate brightness and darkness. But at any given point in space, at every instant of time, light wave from multiple sources overlapping to one another. But there is no interference can be determined in space because of these multiple sources emit different frequency, different phase difference. Therefore, the interference pattern changes continuously every instant of time, and we cannot see alternate bright and darkness can be formed. For interference, the two sources of light wave emit same phase, that is called coherent sources. To obtain the sustained interference pattern, the two secondary sources from same primary sources are obtained. In Young double slit experiment, Young studied the interference of light from one same primary sources and two secondary sources can be determined. The coherent sources can be determined by different method. Young is the one scientist. He studied double slit method, and that is the determination of coherent sources. In this experiment, the two coherent sources making light from single source pass through two narrow slits differ by very small distance, and we seen the interference pattern on screen. This experiment we studied briefly in next lecture. Then second method for the obtaining coherent sources, that is Lloyd mirror. In Lloyd mirror, the light from a source is made to fall at a grazing angle on a plane mirror. This Lloyd mirror can be seen like as this way. Here we can determine in figure, here Lloyd mirror can be determined, and light from source is made that this is the screen, and light from source, this is real source, and they can be travel, and in it can be incident on a plane mirror. Okay, here we can determine same of light fall directly on the screen. The blue light can be shown, that is the figure, that is same sum of light fall directly. This same light can be fall by directly, that can be determined by blue line, and This red light, that is the light can be travel from reflection of light. This can be determined by reflection of light. That is, when we studied that reflected light appear to come from the virtual sources. Here we see that the two sources, and this source is a virtual sources where reflected light can be come. Here also reflected light can be come. Here one sources, that is these two sources are virtual sources, and these both sources having same frequency and same phase. Therefore these two virtual sources are called as coherent sources. Here, this red line and blue lines, the light can be travel from same monochromatic light having single wavelength. This is the second method to determination of coherent sources. Then we can determine by prism. Fresnel is a scientist who studied by prism. By means two. Here two prism can be joined to each other like that. Their angle, vertex angle, that is refracting angles, is nearly equal to 180. That means there is a very thin prism can be joined to each other having refractive angles nearly about 30 minutes or 1 degree. They join like that, their bases are joined to each other, and here biprism can be determined. This is the biprism. This biprism, consider that here we have this two light can be determined. In this biprism, we studied the in experimental arrangement, the refracting edges of biprism is kept parallel to the length of slit, and monochromatic light can be travel from the source, and it can be incident on this refracting edges. This refracting edges, this light can be refracted, and therefore we can determine that the two walls of biprism from virtual images S1 and S2, there are coherent sources having obtained from a single secondary source S. The two wave coming from S1 and S2 are interfere, and they form interfere fringes like an young double slit experiment. That is, in this shaded region, we studied that there is a interference fringes can be determined. That is, alternate bright and dark light can be determined. Therefore, here in most of the coherent sources, we can determine Fresnel by prism, and in Fresnel by prism, we can determine two coherent sources travel from monochromatic light source made to pass from narrow slit, which is shown in figure. That is, here we can determine coherent sources and method for determination of coherent sources. Okay, understood?